Hello, myself Smruthii studying in Sri Venkateswara College of Engineering in first semester in Ferrari section, subject mathematics. So now let's move on to the topic. So my topic is polar curves. Introduction to polar curves. Polar curves are a way of representing the equations and the graphics in the polar coordinates, which use a different systems than the familiar Cartesian coordinates like x and y axes. Instead of describing the points on a plane using x and y coordinates, polar coordinates use a distance r from the origin pole and theta from the reference direction, usually the positive x-axis. In polar coordinates, a point is represented as r comma theta, where r is the distance from the origin to the point and theta is the angle measured counterclockwise from the reference direction. Polar curves are the graphs of the equations involving r and theta. They can represent the various shapes and patterns, including the circles, spirals, choroids, and other intricate designs which may not be straightforward to express using the Cartesian coordinates. Equation of polar curves often take forms like r is equal to f of theta, where r is the function of theta defining how the distance from the origin changes with the angle. Understanding how different functions of theta affect the shape of the curve is essential in analyzing and graphing the polar curves. To plot the polar curves, one commonly uses the values of theta with a certain range to calculate the corresponding value of r and then plots the, plot these polar coordinates on a polar grid where the theta determines the direction of r determines the direction from the pole. Exploring the polar curves can reveal the beautiful symmetrics, interesting patterns, and unique geometrical properties that may not be immediately apparent in the Cartesian coordinate system. They have particularly useful in the physics, engineering, and various fields of mathematics, especially when dealing with the problems involving the circular or symmetrical patterns. Cartesian to polar equations. Common types of polar curves: choroids, limacans, rose curves, Archimedes spirals. These are few types of curves: circle, choroid, one loop, interloop, rose curve, an even rose curve, and odd Archimedes spiral. Graphing the polar curves. Cartesian curves are useful to describe the paths in the terms of horizontal and vertical distances of polar curves are more useful to describe the paths which are an absolute distance from the certain point. One practical use of the polar curves is to describe the directional microphone pickup patterns. Application of the polar curve. Art and architecture. Artists and architecture use the polar curves to create the intricate design patterns and structures such as spiral and circular motifs. Analysis. Polar coordinates can be used to describe the motion of the objects in circular or rotating systems such as amusement park rides or sports equipments. Limitation and challenges of the polar curves. One of the advantages of using polar coordinates for circular shapes is that they can simplify the equations and the calculations involved. For instance, if you want to draw a circle with the radius of 2 units, you can use the equation x into 2 plus y into 2 is equal to 4. The Cartesian coordinates or the equation r is equal to 2 in the polar coordinates. Hope you liked the small presentation of me. Thank you.